In this video, we're going to have a look at how we can draw bitmaps to a render surface. And in essence, this is going to be at the heart, graphically speaking, of our game. So the previous demos, what they've been, I suppose, leading up to, is that we are creating an app suitable for running a game, where we'll have an activity that contains a fragment, and inside that fragment, we basically want to grab all of the screen. And we then want to write our own component that will enable us to draw images and bitmaps to that particular component. And the images that we draw will bring our game to life. We'll draw ones at different positions to show different characters, we'll draw backgrounds, we'll draw things like that. So in this video, we're actually going to have a look at how we can, as programmers, have full control over how we draw bitmaps, to have a surface and we can decide where we want to draw them, what size we want to draw them, things like that. It's going to give us that core point. I'm going to show you two different ways in which we can accomplish this. And the second way is going to be a little bit more complex, so it's going to be involving a little bit of threading. But the reason we do this is that we really want our renderer to be as fast as possible, so we can display images very quickly. And to do that, we want to rely upon hardware acceleration. As opposed to using the CPU inside to draw the images, we want to make use of whatever GPU we have in the device to accelerate the draw of those images. And there's a little bit of work we have to do in terms of teasing that out of Android at the moment, in terms of the current latest version of Android. It might change, hopefully it will change in the future. So we'll have a look, we'll take you through some of the demo code in terms of what we're looking at here. So the particular file is within our demo, it's within graphics, and we've got two down here. So there's two different ways. We've got a surface view. Now this is simply the activity doesn't do much. This is the fragment, surface view test fragment. So we want to have a look at this in terms of what it works and how it works. And there's then going to be another one, canvas thread test fragment. And this will be the one that will be hardware accelerated, which will run a bit faster, but we'll get onto that. So first things first, let's have a look at our surface view. Now, a surface view within Android basically is a view. So it's something that displays, so you have a text view, an image view. These are all simply objects, parts of the screen, which different things are displayed on it. For a surface view, it is a special view that we, as the programmer, can determine precisely what we want to be displayed on it. So I'll have a bunch of images for drawing some text at a certain position, for drawing bitmaps, for drawing lines at different positions. You can sort of think of it almost akin to a canvas, where we can write the code that then gets to determine what is displayed on the screen. And that's perfect for a game. So let's have, I suppose, a look through this. Now, actually, there's one other thing I suppose I should say here. If you're looking at any sensible, decent book on games development, particularly on an Android device, they almost make the assumption that if you're serious about it, you're going to use OpenGL. Because that is a proper 3D programming, and I use it for 2D as well, but it's a proper graphics programming language where you can write programs that will be hardware accelerated on the GPU. For the purposes of this course, we're not going to learn OpenGL. It's going to be just a little bit beyond our particular needs. So we will stick to using non-OpenGL methods, but we're going to, and you'll see for the second example, use a small trick for getting some hardware acceleration. That will give us speeds basically comparable to OpenGL. So we're using sort of the easy way out. But strictly speaking, if you did want to do it proper, you'd be learning OpenGL, because it's a fantastic language. It's a good language to know. Right, so let's have a look at the fragment here, or surface view test fragment, in terms of how it works. We'll go through it, then I'll run it, and you'll have a chance to see how the thing works. But in essence, it's going to be a surface onto which we're randomly going to draw bitmaps, nothing more than that. Now within this here, so this is the fragment. We have a class, we're going to create it for our surface view renderer. So it will be a separate thread of control, if you like, that gets to determine what is displayed in our surface view. And we'll give you a brief overview of the methods in the class, and we'll look at them in detail. So we're going to have our onCreate view. And actually, we'll look at this detail now. So normally on the previous ones that we've seen, when we're creating the view of the fragment, we would normally go off, get a chunk of XML, inflate it, and that would determine what is displayed. We're not doing this in this particular instance. So what we're doing here is that we are creating our surface view renderer, this object here. We're saying is equal to a new surface view renderer, and this will be a class that we will create, and we're linking that view into the activity. Now, whenever you see the class, you'll see that it is a type of view, so we're going to be extending that as a base class, and we're then returning that as the thing that is displayed for that particular fragment. So the view associated with this fragment isn't something inflated from XML, it is a special render that we're going to return. And we'll use that special render for drawing our images and things like that. We have a little bit of things on resuming and on pausing. In essence, if our activity and hence our fragment is paused or resumed, if we have a renderer that is sitting drawn things to it, it makes sense to pause and resume that render as well. We don't want it trying to draw in the background if the activity is meant to be paused and sort of not draining the battery. So if we pause the fragment, we will pause our renderer. Whenever it's resumed, we'll resume the renderer as well. We'll have a little bit down here, and we'll look at this here in terms of the setup for how we're doing it. We'll check that do setup in a method in a second. We'll check the do draw method. This basically, or if you like, or draw what we do when we're drawing the world. The other thing down here is the actual class, the surface view renderer class. So let's have a brief look at this now, because this is the thing that gets to be returned when we create the view associated with the fragment. So effectively, this is going to be determining what is displayed in the fragment. So a few things to note. It's our surface view renderer. It extends surface view. Now surface view is a built-in Android class. It in turn is a type of view. So it's one that is designed to be customized, that you can determine what you display on it. You'll notice here that we're implementing runnable. So this almost harkens back to the notion of the game loop. And we're going to introduce a remarkably simple game loop in this. It runs as fast as it possibly can. But we want to do that. So we're getting control of a surface where we want to display the content, but moreover, we want to display a new set of content 30, 40, 50 times a second as fast as we can. So because we will be changing the contact, we're going to set this up as a thread so it can then sort of try to do this and run as a separate thread of control. As a thread, well, it's something that is runnable. We need to have a thread on which we can run, so we declare that there. We've got our Boolean flag, which is volatile, so I'll refer you back to the game loop demo and lecture in terms of the reason why we have this. So this is the type of thing that we'll use to track if we are currently running or not running our renderer. We've got a surface holder. This is going to turn into the surface view or is associated with it, and you'll see how we use that later on. But basically we need to, if you like, grab or get access to the contents of the screen, then we'll populate and we'll draw it, and then we'll post the thing back up. There's the constructor. So we're saying it's a renderer, a view renderer. We need to know the context that we're linking in with. So this is the activity, and that's important because then we get access to all of the things that the activity has available within that view. We get the holder that's associated for this particular surface view because we're going to be using that, and then we call the do setup method. Now, do setup, this was actually one of the methods we declared above. We're going to jump up here. So this is simply here for the purposes of this demo. It's going to do a little bit of configuration and get us ready for when we're doing our work drawing out the world. So what do we have within this here? We have a variable with the number of calls. So I'm going to try to measure performance here. So every single time we do a draw request and draw things out, we'll increment this by 1. And these things are declared just above. We're going to normally, of course, when you're drawing a game out, you would position the images in careful positions. Here in this demo, we're just going to randomly draw pictures out at different sizes and at different positions. So we're creating a random object, so we don't have to recreate it every single time. We're going to have a rectangle, and this rectangle is going to, because when we're drawing the images out, not only will we draw them at random positions, we'll draw them at random sizes. We'll make some big, we'll make some small. So the rectangle here will hold or will determine the region of the screen that we're drawing to, just how big it is. And when we're drawing things out, we need to have a paint instance, and you'll see these things later on when we have a look at graphics in a bit more detail. The paint, we can use this to determine how we draw the bitmap out. We can give it tints, we can change how opaque it is, things like that. In this case, we're just going to draw it out as it currently stands as a bitmap. So we initialize or create those variables. We then try to load in the image that we're going to draw. So we're only going to draw one image out. So similar to the previous demo when we have a look at asset management, we're getting our asset manager, really the loader, getting an input stream, setting up some configuration options. So here we have a different format to the previous demo in terms of how it's configured. And loading it in using the bitmap factory, decoding it as such, and then closing the thing down. So effectively, it creates things, loads an image, job's done. So let's go back down to our constructor of our surface view renderer. And whenever we do this, as mentioned, we get the holder, we'll see that used in a second, and we do our setup. Now, run then. So run will happen whenever we come in and we resume our fragment. So we'll go through the normal process of creating it, of setting up, of resuming it. So whenever we resume the fragment, we'll kick this thread off. So whilst running, similar to before, we're going to keep doing this whilst the fragment is active. What do we want to do? We've got a few steps down here. First thing is, well, there's a small test here. If the holder get surface is valid, if that is not the case. So in other words, I want to go to the holder. So this is basically the thing that can give me access to the surface view. And I'm going to try to get access to that surface, the bit of the screen, so I can draw to it. Now, depending on creating the application, it's going to take a little bit of time to create the window, things like this. So I might jump in here a little bit quick just before the window's been displayed on the screen. There's a possibility of that because this can be running in a different thread. So this initial check is there to see, just in case this thread jumps off really quick from the start and we get in there before we have a window that we can draw to. If that's the case, then we're not going to try it, we'll just break out of it. And we'll keep on doing that until that window is available for us to draw to. Now, having done that, we go to the holder, which is the thing that basically looks after the surface view, and we ask it to lock it. Now the reason we do that is we want to avoid a situation where if I have a surface view, we can have different threads coming in, all trying to draw to it at the same time. That's slightly chaotic. So if we have a bit of the region of the screen we can draw to, we need to lock it. We need to get exclusive access to it so we determine what's there. Nobody else can get in and get access to it. And that's what the holder provides. It gives us a way of safely accessing that particular view without worrying about other objects trying to get in and getting in the way. Now when we lock the canvas, or lock the surface view in this case, what we effectively get out is a canvas object. Canvas object is actually quite good. So in this here, it actually has a bunch of quite a wide range of methods available for drawing bitmaps or lines or ovals or pictures or text and so on and so forth. So this is quite a rich class. It gives us a lot of control over how we draw to it. We're going to call a doDraw method, which will display whatever we're going to display on the screen. And we're passing it in the canvas as this is what it is displaying to. And we'll look at that in a second, but just look at the final line in our the running while loop. So at this point, after we call the doDraw, so we've drawn our screen to the canvas, then we go to the holder and we unlock it and post. So there's two actions being taken there. The first one is we're saying that we are releasing our exclusive lock on this surface, so other things can come in and draw if they want to. And because we're posting it, that suggests that we made some changes. We now want those changes to be made visible on the screen. So we're reflecting, making those changes visible. And we pass in the canvas that we're unlocking and then making our changes through. And we will repeatedly do that. So we'll go around this here, have the surface, we'll lock it, we'll draw to it, and we'll make that visible and unlock it, and then repeat that. At this point, we'll just jump up and have a look at the do draw method. So as mentioned, normally in the do draw method, this is where you would be drawing your game. You would draw the different layers and position things where they want to be positioned. But in this demo, we're going to simulate a complex process. So we're doing a lot of drawing, just to randomly get the thing out there. Now to do this here, we're going to draw the load of bitmap, not 10,000. We're going to draw it a total of 1,000 times. So it's going to have batch size. You can do it 10,000 if you want to, just slow it down. Batch size of 1,000. We're basically then going to go through or draw into the batch. We're going to randomly pick a rectangle size. So we're drawing the same image out, but we're drawing it at a random location on the screen. Now, that could be anywhere in the screen, and because we're randomly determining the width and the height, it could be big, could be small. We then go to our canvas, and into the canvas we're using one of the draw bitmap methods. There's many. This is the one where we pass an image. The null rectangle here basically means that we are using the full region. This rectangle here is the destination where we're drawing to. So effectively we're drawing all of the source image into that destination rectangle. And we do that a total of 1,000 times. Once we've done this, so that sort of simulates us doing a lot of work, drawing a lot of images to build the game world together. And we probably won't draw, well, it depends on the game. You could be doing 1,000 images per frame. After we have done that, we will increment the number of calls. So basically update our simple, if you like, frame counter. We're going to paint then. We're setting up some things about the text size, where we want it aligned, what color we want to do it. And we're calling another canvas method that says, draw out the following text. Number is equal to number of calls at this position. This is relative to top left of screen. And here's the paint that determines how that text gets to be drawn. So that's us drawing the world out. We're nearly there. So that's the heart, if you like, of our thread that runs around and around. The last two things, again, similar to the game loop, we had a pause, we had a resume. They're responsible for pausing or resuming the demo if need be. Right, so let's have a look at this running then. So we will build the thing. I'm just going to indent with 4 spaces. And if I unlock the device, now down here we have a surface view test down towards the bottom. So I'm going to click on that. And then this is displaying the number of frames. So 20, going up now to 30. And every single frame, I mean, there's massive overdraw here, but we are drawing 1,000 images per frame. You can see some of them are big, some of them are small, random positions, but this gives you a bit of a feel for the thing running and the type of speed at which it can bring about. So bear that in mind. So you can see the numbers going up. We're about 130 going up to 150 frames. Now I'm going to go back. A limitation of the surface view at the minute in Android is that largely it, well, no, I tell a lie. Some elements of the canvas are hardware accelerated and some elements are not hardware accelerated at the minute. If we're drawing bitmaps out, then that unfortunately is something that's not fully hardware accelerated. So it's using the sort of the CPU for writing these things out. So if I were to run this, you can see the speed at which it runs in terms of the number of frames. Now, it's kind of okay for 1,000 frames. I'm going to show you another version now. This is the canvas thread test that we want to have a look at. And you can see there for the frames we're on 100. We're going up then to going up to 200 frames. It is substantially faster. So it's going to be exactly the same process. We're going to be drawing out exactly the same number of frames. In this case, we're going to have a look at this demo next. We're going to set it up so that it uses hardware acceleration in terms of drawing it out. And it is night and day between using the CPU or the GPU to draw out graphics. So we really want to do this because we want to have impressive games. We're drawing out lots of images. Right. So go back to this one. For the surface view, it's fine. You get a bit of a feel for what we do. We get a custom format, but we want to improve upon it to have hardware acceleration. Now, if you want to read a little bit more about this, let me just put this in the screen. There is a handy part of the developers Android guide. So it's one of the developer Android.com guide topics, graphics, hardware, excel.html, and it'll talk through hardware acceleration and how the thing has changed. There's a useful table down inside this that tells you for the canvas which factors are hardware accelerated, which if you call that method, you'll be able to use hardware acceleration behind it. And you can see that, for example, draw vertices isn't currently hardware accelerated. You can see the API level where hardware acceleration came in from them. And I have to say, over time, they've been getting a lot better in terms of doing this. Draw pictures, same sort of draw bitmaps. Meant to be API level 23, but certainly the emulator that I'm running here is using API 23. Doesn't seem to sort of be building upon it to the extent that it should be. But it has been changing over time, so there's definitely improvement there. Now, let's go back then and have a look at how we can use this sort of simple trick to try to trick things into use hardware acceleration to get that sort of speed up. And I want to, well, actually, I'm going to show you this one first of all, because there's a little bit of theory behind this before we have a look at the code. Over on the left-hand side, you can see the surface view configuration. We have our thread of control, which runs the user interface and is sitting there accessing touch events and so on. Now, interesting fact, the GUI thread or the GUI thread is by default hardware accelerated. It is one that uses hardware acceleration. So if we draw anything through the GUI thread, bitmaps or things like that, they're hardware accelerated. But if I have my own thread of control, and I do have my own thread of control within the game because we need to have our own loop that is ticking and saying update things and draw things. So that runs in a different thread. And as a reminder, we had to do that because we don't want to stick it all on our user interface thread, because we want our user interface thread to be there looking for the player touching events, recognizing these things quickly and giving them into our game. So in this one here, we had two threads of control, and our surface view has been updated in the other thread, if you like, the non-GUI thread. So effectively there, okay, in the demo we were only drawing. That's all we were doing in the demo. In the game we'll be updating and drawing, updating and drawing, updating and drawing. But it would be done, so to speak, on this particular thread, the surface view thread. What I'm going to show you for the canvas renderer next uses a slightly different setup. We still have two threads. We've got our GUI thread, and we're going to have our main game loop, if you like. Inside the main game loop, we will update objects, but we're not going to draw them in that thread. Rather, we will send a request to the GUI thread and ask it to draw them. And because the GUI thread is hardware accelerated, it will draw them in a hardware accelerated manner. It will draw them faster than the other thread, considerably so, as you saw. So we're going to have this set of two threads which are kind of, which are linked to a degree, where we do update in one thread, that thread then requests a draw, which is picked up by the other thread. We do an update in this, request a draw, and is picked up in the other one. So that's going to be the relationship we're going to try to tease out of this. So let's have a look at how we can do that inside the code. And actually, the code's probably simpler, to be honest, but the thing you want to get in mind, the difficult thing, is you're looking at two threads that are running where one is telling the other one to do something or putting in a request to it. So that's the only complicated bit. Now, if we're looking for this, most of it we're going to go over quite quickly because most of it will be exactly the same. Now we have a canvas render as opposed to our surface view render, but it's the same idea. It's going to be a view component where we're going to control what is displayed. When we're creating the view, we create our canvas render and that is returned. So again, there's no inflating of XML. We are creating our own view to determine what is drawn to it. For resume, for resume and for pause, exactly the same pattern. If we resume and pause the fragment, we do exactly the same for our renderer. For the setup and draw methods, same sort of stuff. Do setup, exactly the same. For the methods that's drawn there for the do draw, again, it is exactly the same. We should delete it. To do this, just put it back in to make it right. It is 1,000 times. So the batch size is 1,000 in both cases. There's no cheating happening here. Same work is done. Again, drawing it at random. We're displaying the same frame count as before, so no difference. So the canvas render, this is our new class. And it extends the basic view class. So it's not a type of surface view, it's just a basic view, nothing more than that. But it is a runnable object. So it will do and execute in its own thread of control. Same as before, we have a thread in which we can run it. We got all of our usual running flags and things like that. But we have a new method now, a new method variable. So draw needed. It's volatile, which means that this is something that both threads, the GUI thread and this sort of update running thread, will change. And as you might guess, the name suggests that if draw needed, if it is true, that suggests that we have made our changes or we've done our update and we want to draw to the screen. If it's false, then that suggests we haven't yet updated the game, we don't need to draw it yet. So we're going to use this Boolean value as a means of communication between the two threads, so we'll sequence it. And it's only when we need to do a draw that our GUI thread is going to pick up on that and actually do it. And we'll use that to control the two, and you'll see that. For creating it, we do our setup, that was loading in the stuff. For running it, it's actually quite straightforward. I'm going to come back to this in a second, just want to go down to the bottom. You can see here we do have an Ondraw method. We didn't have that. Well, we have it now in this one, we'll have a look at that. We've got a pause and we've got a resume. So pause and resume, identical, they don't change. So the things that do change are what we have here. A little bit about a run, and we are putting in an intermediate Ondraw. So the run method, first of all, while running, same sort of thing as before. I'm going to do the following. If we need to draw, so remember, we will need to draw once we've updated all objects and are now in a position where we want to reflect the new state of the world to the screen. So initially, well, sort of false is the flag that comes in, so it's not going to happen. If we don't need to draw, then we don't do anything. If we do need to draw, so if draw needed is true, then we are setting it to false. We're basically consuming that event, and we are calling invalidate. Now, we need to be careful about what this is. So all view objects have an invalidate method. Actually, there are two. They have invalidate and post invalidate. So I can go to a view. It could be a surface view. It could be a text view. It could be this canvas view. And if I call the invalidate method, what it means is I'm basically saying the contents of it has changed. It needs to be redrawn. So this will act as a trigger to the GUI thread that it should redraw the thing. So that's how we can ask, so to speak, the GUI thread to redraw the object. Now the difference between invalidate and post-invalidate is that post-invalidate is intended to be used if you are requesting a draw from another execution thread, another thread of control. And because this is running as a separate thread from the GUI thread, we've got to use post-invalidate, so it sends the message across to the GUI thread. It'll pick up on it and it'll draw the thing. So that little piece of code there, whenever we say that we do need to draw it, we're going to reset it back to false, so this is our way of going back to the start, and we will send in a request to the GUI thread that you should draw the thing. Good, hopefully, so far. What do we do then? We then sleep for 10 milliseconds. So this is my remarkably simple game engine. I'm capping this at 100 frames per second. I'm not doing anything fancy by way of trying to time it. I'm simply going to say, go to sleep for 10 seconds, and then wake up. We'll come around this loop again. Now, if draw needed is true, then we're not going to do anything there. Oh, sorry, so draw needed is true. Yes, we are. We're going to take the thing. If it is still false, so for example, we go to sleep for 10 milliseconds, we come around, we check draw needed, and it remains at false, then we're going to go to sleep for another 10 milliseconds. We'll wake up again, we'll come along. If it's still false, we'll go to sleep for another 10 milliseconds. So this one loops around. Anytime it finds draw needed to be true, then it sets it back to false and draws the screen. And it repeats. Now, you're probably sitting thinking, wondering at this point, okay, who sets it to false? Because this thread of control never sets it to false, and you're right, it doesn't. For this thread of control here, it is going around setting it, who sets it to true? This thread of control is going around setting it to false, invalidating it, drawing the thing. So who then sets it back to true to actually enable the thing to be triggered? Now, where that happens is down in this particular method, Ondraw. So with the Ondraw method, we draw out whatever's on the screen, and we're being passing here a canvas object. So this is a different Ondraw to the previous one. This Ondraw, whenever you're called with it, you get a canvas object, you can draw yourself out to that canvas object, and then we're saying draw needed is equal to true. Now, for getting your head around this here, so all view methods, you can see this is an overrided method. All view objects will have an Ondraw method. You can overload it, and you will overload it if you want to control what is drawn to that particular component. So if you had a text field or whatever, and you somehow wanted to have a real custom or fancy text field where you had your own fancy graphics, you could overload the basic one to say, okay, I'm going to determine how the text field is drawn. Now, we're doing it for a game, but we do want to have control. So for this particular view, we're saying that yes, we want to overload the Ondraw method so that whenever we are called and given a canvas object to draw, that we will draw what we want to do to it. And then we set our draw needed equal to true. Now, the thing to get your head around in this here is that this chunk of code is effectively run on the timing thread, the one that is there basically ticking and saying, okay, updating objects, okay, why don't we try and draw them now, or putting in a request. This chunk of code down at the bottom here, the Ondraw, is run on the GUI thread. So we've got two methods that are run on different threads of control. This one, which is run on our timing one, its job is basically notionally to update the objects, and then whenever they're updated, to ask that they are drawn. Now, that will go to the GUI thread. The GUI thread will pick up and say, I need to draw this, I need to invalidate this. So it will invalidate it, it's going to go to the view, and the GUI thread will call the view's Ondraw method and pass in a canvas that it can use to draw itself. So the GUI thread will request that we draw itself. So in that GUI thread, we're calling the Ondraw. We're doing exactly the same draw as we did before, and this is the reason why we have this as a volatile flag. Now we're changing it back to true. We do need to draw because we've drawn the previous one out, so we can draw another one. Can be a little bit hard to get around in mind, but think about these two things running independently on different threads of control. They interact with one another through that draw needed flag. And that gives us a way of having this separate thread of control and then triggering the action on the other thread. So, slightly complicated bit to end on at the end in terms of how these two threads interact with one another. But certainly in terms of how fast it runs, if we're not doing that, if we're using the CPU to draw, versus how fast it runs if we're using the GPU, it's worthwhile spending a little bit of time getting your head around that just to understand how the thing operates.